So welcome to the coveted after lunch slot where I slowly talk you to sleep with a monotone. Hopefully not. The first cat picture is like 4 slides in, so if you guys stay with me, hopefully it'll be fun. All the slides and links for this talk are available right now at this short URL, so you don't have to worry about copying down any links that I talk about in the slides. As Steve said, I'm a performance engineer at Etsy. I write the Etsy site performance reports, which if you haven't seen, these are where we publish our front-end and back-end performance numbers every quarter and talk about how they've changed over time. I also started the Boston Web Performance Meetup group. And today I want to tell you a story. This is a story from your future. So you spent the last few days at Velocity learning from the best in the industry. And when you get home, you're going to need to sit back and think about what the key takeaways are from the conference and what you should do right away. You may have learned about things like origin hints, client hints, WEPI, speedy, prefetching. And when you look at a list like this, it can be very easy to wonder what you should implement. My objective today is to make this story have a happy ending by showing you which optimizations are going to have the biggest impact for the smallest time investment. So let's start at the top, origin hints. Now, origin hints are currently in IETF draft, and they're implemented as an HTTP response header. The purpose of them is to tell the browser about server capabilities. So an example, it might look like this. You have this OH header designation, and then a hint, another hint with a value, and then a third hint, etc. The kind of things that you'll see in origin hints are hints like small request headers. This tells the browser you don't need to send an accept or accept character set header, and you can send a short user agent string. You might see relative refers. This is exactly how it sounds. You can send a relative refer URL in the refer header. Omitting cookies. This is a way to say, for this domain, don't send any cookies. Sharing connections. This allows you to have the same or different host names that point to the same IP address share a TCP connection across those host names. And then finally, pipeline depth. This tells the browser how many parallel resources to get from the same domain. The purpose of origin hints is twofold. One is to reduce header size, and the second is to optimize the transfer of the content to the browser. It doesn't require any content changes, but it's also somewhat of a micro optimization. These things are the kind of stuff that's going to get us to that 1 second time to glass, but it's not going to be a big impact on the overall page load time. So if we were to kind of grade the origin hints, you might say, well, browser supports nothing. It's currently just a draft. The impact when it is coming out is going to be fairly low. It should be fairly easy to implement, but we don't know yet. And future potential is pretty modest. So you can kind of cross this one off the list, something to keep an eye on, but it's not something you can go home and do today. Next up, we have client hints. Now, client hints are kind of the opposite, the flip side of origin hints. It's another draft spec. This one's presented by Ilya Grigorik. This is implemented as a request header, so the browser is sending this to the server. And again, this tells the server about the browser capabilities. So think about kind of the opposite side of origin hints. And the header, again, is pretty simple. Client hint dash DPR, that's for device pixel ratio, is 2.0. So the idea here is to tell the server explicit details about what the browser capabilities are. A full request response cycle might look something like this. You have the typical get. You can see that DPR 2.0 header in there. And then the response comes back with a 200, some server information, content length. And then most importantly, you can see this very CHDPR header in the response. What this does is it tells any caches, whether that's a CDN or any other intermediary cache, to use this client hint header as part of the cache key. This is important because client hints allow you to serve different content on the same URL. A specific use case for this is Retina images. You want to serve, instead of having a picture element or picture fill or some other thing like that in HTML, you actually have the same URL serving 2 different images depending on the device pixel ratio that you see from client hints. And because of that, you have to vary the cache key based on this DPR header. They're also going to specify height and width, so you don't have to guess at that by user agent either in the future. And the goal here is to kind of simplify the markup, not have to have all that logic in your HTML. When we look at our grade, pretty similar. Browser support is 0, but it's important to note that the code for this is actually already in Chrome. It's just hidden behind a flag currently. So this is something that hopefully in the very near future will be available in Chrome. Impact is going to be modest. I think it's more of a maintainability win than it is on a performance win. But hopefully it will enable people to have an easier time of doing the right thing when it comes to performance and responsive web design. Very easy to implement. You can look for this header in one piece of your code and serve the right content, no problem. Future potential, modest but decent. OK, so that one's also probably not something you're going to go home and do immediately after this conference. And at this point, maybe you're getting a little bit grumpy. What's the point of new standards if you can't actually use any of them? So let's keep going down the list, and I promise it's going to get better very soon. Next up, we have WEPI. Who's actually heard of WEPI here? Okay, maybe a third of the audience. Who is implementing it on their site? That's like 5 people. Okay. So WEPI is a new image format from Google. Some studies they've shown that it's about 25 to 34% smaller than JPEG. It has a lossless option, alpha transparency, as well as animation. So when you see this, you should be thinking, lossless and alpha transparency, that kind of takes the place of PNG. Animation takes the place of GIF, and then it's smaller than JPEG. So the real goal here is to have one image format that rules them all, right? One image format designed for the web that handles all of the use cases on the web. If we look at browser support, right now it's only Chrome, Opera, and Android, which might not seem like much, but if you see the global number in the upper right, that's still about 40% of the global usage, which is pretty decent. So you can say now we're actually getting somewhere. We can actually test this out and see what kind of impact it has on a real site. This is a demo page. This is a semi-real site. This is basically just a simple press-to-shop template, which I picked because it's got a kind of somewhat realistic out-of-the-box template. Run this through web page test, get a result like this, and the key stats here are 576 kilobytes, start render of about 900 milliseconds, and speed index of 1269 milliseconds. This is before we made any changes. There's just out-of-the-box performance. And before we go on, I want to take a brief moment and talk about speed index. Speed index is a metric that was built by Pat Meenan as part of web page test, and this is kind of the way to conceptualize it. Both of these graphs, on the x-axis we have time, and on the y-axis we have percentage visually complete of the page in question. So we're graphing how complete the page is visually over time. And then speed index is taken as the area above the curve for the whole duration of the page load time. So on the left here, you can see it almost fully completes very early and then takes a long time to finally complete. And then when it's done, it closes that off, and this blue bar is the speed index. On the right, kind of the opposite. It goes about 18% complete for a long while, and then jumps to 80 or 90%, and then finally finishes. So this is a much larger speed index. And you want speed index to be small. The way to think about it in general is it's kind of an average time at which elements on the page appeared. So it's a good way to quantify the visual appearance of the page, which is really what end users care about. How long did it take for the major page elements to show up? When you see something like this can often happen when you have one big banner image in the middle of the screen, like a lot of sites do, one big kind of hero image. So the site Chrome will come in pretty early, and then you'll finally wait to download this entire thing and then get quite a large speed index, because that's the majority of the page. All right, so now that we understand speed index, we can understand what it means to move that metric. Let's take our example page, and let's convert the JPEGs to WEPI. Run another web page test, and then look at the key stats. We dropped about 33% off the kilobytes on the page. Again, these are just normal images off this template. Run them through the command line converter to convert from JPEG to WEPI, and this is what we get out. So this is towards the upper end of the range that Google said is the typical reduction versus JPEG. Our start render jumped a little bit. Now, this could be sampling error. It could just be random. There's also one downside of WEPI, which is that it takes about 1.4 times as long to decode versus JPEG. So that could be why the start render time is slightly higher. Speed index, almost no change. And this is actually expected, because speed index, again, is about the average response time of the page. The images, they might be a little bit faster to download, but overall, the whole page isn't going to change a whole lot just by changing the image. The big win here is the number of bytes that's been reduced. So if you have a lot of customers that are on a slower connection or international, that's where your big win comes into play. If we look at the grade for this, browser support, about 40%, so we're getting somewhere. The impact can be large, as I said, especially if you have bandwidth considerations. And this isn't just for your clients, your end users. It's also for your own data center costs, your own CDN costs. Reducing your bandwidth can save you a lot of money. Depending on how big your working set of images is, the implementation can be either very easy or pretty hard. If you have thousands or tens of thousands or even hundreds of thousands of images, you can run a command line script to convert them all to WEPI and store them all pretty easily, no problem. If you're like Etsy and you have a few 100 million images, it can be a bit harder. And then feature potential, I'd like to say it's strong, but the reality is that the future is somewhat uncertain. A little while back, Facebook tried converting all of their images to WEPI on their site. And there was a little bit of pushback. And basically what happened is the first challenge with WEPI. One is that they're harder to share. So people would try to download these images and send them to their friends, or even send a link to their friends. And if their friends weren't using Chrome, they couldn't view the image. So that's why people were complaining about WEPI on Facebook. I also mentioned there's that increased decoding time, about 1.4 times the time to decode a JPEG. Not the end of the world, but that can have an impact, especially on low-power devices like mobile devices. And there have been some controversial studies around quality and size. Mozilla specifically is a little bit skeptical of the results out of Google. And then finally, the last thing that's a challenge is that it currently does not have progressive decoding. And if you read the advent calendar, performance advent calendar, you know that the progressive JPEGs are currently a best practice because they render in progressive scans as opposed to from top to bottom. So it would be nice to see progressive WEPIs as well. But again, I want to point out that even though these things are a little bit challenging, it can still be a big bandwidth win. And depending on how many of your users are on Chrome or Android, it can be a great option. As a specific example, the Chrome Web Store obviously is being used by only Chrome users. So they converted all those images to WEPI. They get 100% coverage. And that's a huge bandwidth savings for Google. So this is something that you can definitely put on your list of items to check out when you get back. Again, if you have a small working set of images, the cost of testing this can be very, very low, and the benefits can be high. Let's move on to Speedy or HTTP 2.0. For the remainder of this presentation, I'm going to use these interchangeably. So Speedy is the protocol developed at Google that is the precursor and test bed for HTTP 2.0. And HTTP 2 is going to be the official finalized spec once it's done, and then Speedy will be deprecated. So I'm going to kind of use these as the same thing going forward. Is anyone using Speedy on your site today? Okay, we got another like 4 or 5 people. Maybe the same guys who are using WEPI. Well, hopefully I'm going to change your mind about that in a minute. So this is going to be the next version of HTTP. It's the next major version in like a decade. The big thing people always talk about with Speedy is HTTP multiplexing. This means you could have multiple HTTP request response streams going over the same TCP connection in parallel. So that sounds kind of complicated, but what it means is that you can request a bunch of CSS, a bunch of images, all at the same time on the same connection, and the responses for that content can come back intermingled. And Speedy is intelligent enough to match up the responses with the requests and recompile the content on the client. So the big win here is that it immediately removes the overhead almost entirely of an HTTP request. So one of the big rules in web performance for the last 10 years or so has been reduce HTTP requests. Well, with Speedy, you no longer have to worry about that. Essentially, it makes them cheap and almost free. The next thing it has is header compression with a new system, a new compression scheme called HPAC. They initially tried it with gzip, but there were some security issues, so they built HPAC specifically for Speedy. And one of the problems with HTTP headers today is that across multiple requests, there's a lot of duplication. So if you request one image from a domain and you request a different image from the same domain, probably 90 to 95% of the bytes in the headers are going to be exactly the same across those 2 requests. So HPAC is a good way to reduce that redundancy and really, again, eliminate some of the overhead of an HTTP request. So if you're multiplexing streams and you have header compression, the cost of an additional request is super low. So Speedy also has prioritization. This allows you to say, I want the browser to download this CSS file first or this image first and then defer the rest. And it finally has a server push. Now, server push can get a bad rap. People say, well, I don't want the server shoving resources down the pipe at me that I don't want. But the way to think about server push is it's basically the same thing as inlining. If you inline an image with data URI or you inline CSS or inline JavaScript, you are pushing content to the client. Server push just gives you a more effective way of doing that by pushing an actual full HTTP resource at you so that a browser can cache it, intermediate CDNs can cache it, and you can kind of do it on demand. So just think of server push as a more efficient way of inlining content. And remember when we talked about origin hints, one of the big benefits it had was reducing header size. So you might say, well, we now have reducing header size, but we have header compression as well in Speedy. And the point here is that Speedy kind of invalidates one of the big benefits of origin hints. And my point is to have you think about what optimizations can you do that will eliminate an entire class of performance problems. And Speedy is a great example here, where by implementing it and just Speedy, you're going to solve a lot of problems you might have in your site without having to do anything else. And so maybe you just say, you know what, forget about origin hints. Even if they're finally adopted and put in browsers, header compression solves most of those problems for us. Another example here might be mod page speed. If you've heard of mod page speed, it's essentially an Apache module. There's also an Nginx module for it that lets you do many optimizations in an automatic fashion on your site. So it's a way to kind of save time and do a lot of the work for you in one go. One of the best parts about Speedy is the browser support. So there's a lot of green on this chart. You can see that the latest version of every single browser vendor now supports Speedy. And that includes Safari on iOS 8 and on Yosemite. And you'll notice here on the left, there's a sort of weird color for IE11. That's partial support, and what that means in this case is that IE 11 on Windows 7 does not support Speedy, but IE 11 on Windows 8 does. Don't ask me. And IE 12 is going to support it everywhere. So we look at the global numbers, we're at about 60.86% right now, but once people start upgrading to iOS 8 in Yosemite, this is going to jump dramatically. Most of the missing 40% is in iOS users, right, or macOS users. So that's going to be a huge win, and that was announced a couple weeks ago. So as we talked about, this really reduces the overhead of HTTP requests. So this means, number one, no more domain sharding. Because you can parallelize multiple requests on the same connection, there's no reason to shard domains. You can get as many requests as you want on the same domain. No more spriting images. The overhead of an additional image request is so low, you don't need to sprite them. Forget about concatenating your JS and CSS as well. That's something you can just forget. And then data URIs. Because of server push, we don't need to inline content anymore. So all these things are kind of improving upon the limitations of HTTP 1.1, and it's really great that HTTP 2 is going to remove the need for us to do them. And remember, these optimizations, these are actually really hacks. They're hacks to get around the limitations of the current protocol. This isn't stuff that developers should have to worry about, so it's nice that browser vendors and protocol designers are finally kind of handling these cases for us. If you want to learn more about the Speedy or HTTP 2, I'd highly recommend Ilya's book. There's a link to this. It's free online. There's a link to this at the short URL that I put here. OK, so that's Speedy. Let's actually see it in action. So we go back to our test site, run another test here. And then I think the most useful way to look at this is with the connection view. So this is before Speedy. You can see we have 6 connections that have been made to the domain. Now, this is the default for most browsers. I'm using this in Chrome. Most browsers today will open 6 connections in parallel to the host. And that's basically designed to parallelize resources across those connections. So you'll see every resource is coming from the same domain. So we get 6 connections, and then you can see them kind of coming down as quickly as possible. After Speedy, we have 1 connection. Now, the big one here is you see 1 DNS lookup, 1 TCP connection, and then 1 TLS negotiation. So in the previous slide, every single one of these connections had to make the connection. The DNS lookup's cached, so not a huge deal. But every single one has a TCP connection as well as a TLS negotiation segment. So by eliminating those with Speedy, you not only save resources on the client, but you also save resources on the server. It's many fewer TCP connections that your server has to handle. And then you also might notice at the bottom here on this bandwidth graph, once we get through the initial connection and negotiation part, we get a small CSS file, and then the bandwidth graph goes up and stays high consistently. And this is what you want to see. You want to maximize the use of bandwidth. And this is really what Speedy allows you to do, is use your bandwidth to the fullest by parallelizing requests across the same connection. If we look at our key stats, this is after we've added WebP, so we're still at that smaller byte count. Our start render went down a small amount. So since Speedy is kind of impacting the download of images and other assets towards the end of the page load time, we don't expect start render to change a whole lot. But our speed index did change quite a bit. So we got a 14% decrease in speed index overall. And that's pretty solid. One of the great things about Speedy as well is that it works even better on poorly optimized sites. So if you have a site currently that has hundreds of HTTP requests, isn't concatenating its files, is not spriting, that's where Speedy is really going to shine, because it eliminates all the downsides of that approach. All right, let's look at our grade for Speedy. Browser support, about 60%. Probably pretty soon going to be around 80% in a few months once Safari and on both iOS and on macOS gets upgraded. Impact is really high. This is probably one of the most impactful optimizations that's coming down the pipe for web performance. Implementation is fairly easy if you're running Apache or Nginx. There are modules for both of those. And in fact, in both cases, Mod Speedy is going to be part of Apache Core very, very soon. So the implementation details are quite straightforward. The only thing is it does require HTTPS currently. So if you're not serving your site over HTTPS, number one, you should do it for security. But number two, you should do it for Speedy. And some people get a little bit concerned about the performance of HTTPS. But there's actually another session later tomorrow called Is TLS Fast Yet? And I'll send you the time for that a little bit later. But that's where Ilya is going to talk about, TLS actually isn't a huge decrease in performance. Like it's actually a decent, it's almost on par with HTTP. So this is why HTTP 2 is the protocol full of win. And I think it's the single most exciting change that's coming to the web. And the protocol itself, the finalized HTTP 2 version, has a good chance of being done this year. Some sites using Speedy today, most, maybe even all of the Google properties using it, Facebook's using it, Twitter, and about 5 of you apparently are using it as well. So this is something that I would definitely go home and try to check out pretty much immediately. OK, last up we have prefetching. And in this context, I'm talking specifically about asset prefetching. So CSS, JS, and images. I'm not talking about pre-rendering. These are two different things. There's link rel pre-render and link rel prefetch. And the reason why I'm not talking about pre-rendering is that there's some challenges around analytics with pre-rendering, around generating extra requests to your backend. It's not necessarily a bad thing, but it is a little bit more complicated. Asset prefetching is a little bit more safe. So let's talk about that. So we're talking about prefetching, which is fetching assets for the next page you expect the user to go to. And the idea here is to speed up navigation. And the implementation, very, very simple. It's just a simple link tag, link rel prefetch, with a link href to the resource you want to fetch. To test this out, you can write a simple web page test script. So turn off data logging, log data 0, navigate to some page, turn data logging back on, and then navigate to a second page. What this is going to get you is only the results in web page test for that second page, since you weren't logging data for the first page. So this is a great way to see how prefetching impacts your site. So this is the result before I added any prefetching. And it looks like this. 85 kilobytes, which is pretty low, but again, someone's already seen the home page and then they've gone to a product page, so they've gotten kind of the core site CSS and the core site JS, so they're only pulling down a few images on this page. Speed index is half a second, but we're still downloading 2 CSS files and 6 JS files. That seems like maybe a lot when we have prefetching available to us. So let's fix that. All we do is add 8 link tags for those 2 CSS files and the 6 JS files. This is literally the entire implementation of prefetching. You know what's on the next page, so you put it on the first page in link tags. And then we run another test. We get a 40% drop in both bytes and speed index, and we see all those CSS and JS files go away. Now, this may not seem like much. We didn't save a whole lot of content, 85 kilobytes to 50 kilobytes. But speed index dropping from half a second to 290 milliseconds, this is the difference between a page feeling like, pretty fast to feeling almost instant. So this can be quite a large win for a pretty small investment of time and energy. Browser support today, it's only supported in Firefox. But again, Chrome actually has the code in it right now. It's just behind a flag. So the hope is that this will be turned on in the near future, and then that'll jump support up to maybe 60% almost overnight. Impact can be pretty large. Etsy is actually running a test on this right now, and we're waiting for results as I speak. But hopefully we're going to see some positive impact from that. As we saw, the implementation is about as straightforward as it gets. All you have to do is add a couple link tags on your site, and you're off and running. And then feature potential, I think, is actually quite high. When we saw, some people worry about prefetching, and they say, well, we're going to be shipping a lot of extra bytes to the client we don't need. But you saw we fetched 8 resources, 6 JS files and 2 CSS files, and it was 35 kilobytes of content. That's almost nothing. So when you're only fetching CSS and JS, which are kind of the critical resources to prefetch, you're not going to use the bandwidth of your user too much. And the reason why I say they're critical is because if somebody has CSS and JS completely in their browser cache, as soon as the page loads, they're going to immediately start getting images and displaying content. So you're really going to drive down that time to start render. All right, so this is something that I highly recommend testing out as soon as you get home, primarily because it's so easy to try. Now, throughout this, we've kind of seen that browser support isn't that great. You may be feeling a little bit sad about that. In fact, Speedy is really the only thing we talked about that has really quite wide browser support. But the key takeaway here is that these are still good options. Some support is better than 0, and you can handle different clients in different ways. Speedy is a great example of a protocol that downgrades very, very well for older clients. So if a client supports Speedy, it'll get upgraded to Speedy. If it doesn't, no problem. It'll still operate perfectly fine on HTTP 1.1. As well with WEPI we talked about. Now Chrome and Opera and the Android browser, they're sending this accept header that says accept image WEPI. So you can just check for that accept header. If it's there, serve the WEPI image, and if it's not, then don't. This makes it very, very safe to test out WEPI. If the header's not there, you're immediately defaulting to a case where you're going to serve an image that you know the browser can support. So even though it's not super wide support, you can still get a nice benefit for the users that do handle these things well. Another thing to think about is that convincing CDNs would be huge. Etsy has 3 CDNs, and currently only one of them offers Speedy as an option. Since we terminate TLS and TCP at the edge nodes of our CDNs, to get any value out of it, that's where we really need to have that Speedy connection. And that's actually a best practice, right? Terminating your TLS and your TCP at the edge is great. But if your CDNs don't support the new standards, then you're kind of at a catch-22 situation. There are also some implementation challenges. As I said before, with Etsy, we have about, 500 million images. So our working set is extremely large. It makes it very, very hard for us to test out WEPI. We can't really convert every single image on our site to WEPI, store all 500 million of those, and then go forward from there. It's just we don't have the storage space. We don't have it would take months to recrunch all those images. So it's not really an option. But if you have a smaller site, you have a smaller working set of images, then it's pretty straightforward to do. And then prefetching, prefetching is very easy to set up, but it has low browser support. So when you think about all this, it's like, what are the action steps? What can I actually do today that's going to make a difference? So number one, implement as much as you can. Try this stuff out, and when you find challenges, blog or speak about those challenges. Go ask your CDN for support. The reason why the CDNs don't have support isn't because they don't believe in the protocol or because they don't want to. It's because they haven't had a lot of customers begging for it. But if you do ask them, you can move the needle on that. And then finally, report bugs. At Etsy, we actually tried to roll Speedy out. We said, you know what, let's actually try bypassing our CDN and then just serving Speedy from the origin and compare the two. Is Speedy from the origin better than non-Speedy from our CDNs? So we used F5 load balancers. We upgraded to a stable version that supported Speedy, and we turned it on. And almost immediately, we found a bug in F5's implementation of Speedy. And had to report it to them and turn it back off again. And that was like 3 months ago, and we still haven't heard back from them. So this is the kind of thing where the browsers have implementation in place, but the vendors, the server-side technology may not be as robust as it needs to be. So by trying this stuff out in the wild, trying it on different sites, that's how you really provide the feedback that's very necessary for the vendors to check out. I mentioned there's some other talks of velocity you might want to see. The TLS is fast yet. That one's at 3:30 tomorrow. There's a Chasing Waterfalls talk at 5 tomorrow, and this What Makes Mobile Websites Tick today at 3:30, excuse me. These are all talks that might go into more depth about what components are on the web, what protocols are going to help us, what are these things going to impact over time. So I'd maybe think about checking those out as well. I have office hours as well if you want to talk to me at 3:30 today. And we can talk more about standards or web page tests or anything else you want to know about. So I actually have quite a bit of time left for questions, but let's work together and upgrade the web, and thank you. All right. I think there's a mic in the front if you want, or you can just shout it out if you're close enough.
So is there a reason you didn't have IE11 for your prefetch support?
Yeah, I didn't know that IE11 supports prefetching, does it?
Yeah, it does.
OK. Apparently, IE11 supports prefetching. Who knew? Yeah.
On the prefetch for the next page, right? So you're testing for that. What's the impact on that first initial page?
Yeah, so the question was, you're testing for prefetching impact on the subsequent page, but what's the impact on the first page where you actually have those link tags? Almost nothing, right? So the browser knows to prioritize prefetch resources as low as possible. So what it's going to do is it's going to actually download the rest of the page, and then at the very end, it's going to pull in those final resources. And if you look in the network panel in Firefox, when you put this on your site, you'll see those resources come in at the very end. So it's not really going to contend for any bandwidth. Those requests are backgrounded. They're obviously not executed on the parent page. So there's really no downside to having those on the page.
On one of your slides, I think you showed like nice increases in like speed index and everything that didn't show any drop in the volume of traffic being transmitted.
Yeah.
How come that was? Since you would have thought with the header compression, you would have seen some increase in overall.
Yeah, so the question was, on the Speedy example, we saw a nice drop in speed index, but we didn't see a drop in kind of server resource utilization or bandwidth, right? The simple reason for that is that I did a synthetic test on a demo page. So I didn't really have any way to gather data across many requests from lots of clients. But that's a great point, right? I mean, you're going to see a nice reduction in resource utilization on the server side just from a drop in connections, as we talked about, a drop in TLS negotiation, et cetera. So yeah, that's going to be a big win there as well. It's just that for my synthetic test, it was hard to show.
Have you heard about header suppression? Like a shutter from Qualcomm, where the server and the client maintain a dictionary of the headers that change?
Yeah, so header suppression it's called. Yeah, header suppression where the server and the client maintain a dictionary of headers that don't change across requests. Yeah, I'm familiar with that. I think once Speedy is widely supported, which it kind of already is, that sort of becomes a moot point. I think Speedy kind of handles that pretty well. But it's something that you could think about as well if you're kind of in that intermediary stage where you can't quite roll out Speedy.
Have you done any tests with Speedy using two TCP connections? Like you could do it with domain sharding. I would think two would be better than one.
So the question was, is two TCP connections with Speedy better than one? I haven't personally tested that. I would expect that because of the parallelization, as long as that's good enough, you're not going to really see a big benefit from two TCP connections with domain sharding, because you pay that DNS lookup and you pay for that other connection. But depending on the composition of your page, I suppose it's possible that's going to be a win. Do you have a?
So break your dictionary, right? Your compression dictionary.
Yeah, the compression dictionary is not effective if it's across multiple domains. Yeah. Yeah, it's an interesting thought. I mean, it's certainly worth trying if you feel like you have content that's going to benefit from that, but that's pretty easy to see with web page test, right? You can change it to 2 domains, run a test, change it to 1 domain, see how it goes. But that's kind of the whole point, is that with Speedy, since you can parallelize those requests, once that first connection's set up, you just kind of shove everything you can down the pipe, and there's no sort of downside to having the 1 domain. Yeah. JPEG Mini, we're not using that at Etsy now. I mean, this is part of the problem with the large working set of images. We actually wanted to test progressive JPEGs as well, and we started to run a test, but the problem is, since the working set's so large, even converting our JPEGs to progressive is kind of prohibitively difficult. So what we tried to do is generate them on the fly. So we say for any request that comes in, generate a progressive JPEG on the fly and serve that back to the client. But in order to do that effectively, you have to make sure those images get cached on the CDN. You have to make sure you have enough capacity in your server to kind of handle those thousands and thousands of requests that are coming in. And so it is really challenging when you have a large working set of images to try new image formats. But if you have a smaller working set, then it can be quite easy. In the back. How do browsers feel with non-cacheable prefetched objects? Interesting. So if you prefetch an asset that doesn't have a caching header, I'm guessing they would throw it away, but I don't actually know. But in any case, this is for static resources, not for full pages. So they really should have caching headers, both for performance without prefetch and with prefetch. Yeah. Right, so that's like pre-rendering, right? If you're pre-rendering an entire page, like an actual link, then there are some challenges around cacheability and freshness and what happens with the data on that page, et cetera. So that's one of the reasons why I didn't touch on it. I think that it's a lot more complicated, and there are a lot more challenges with a site implementing it, whereas prefetching, you can basically put it on your site today, and there's almost no downside. Does speedy header compression work for cacheable and non-cacheable content? I believe so, yeah. Kind of talk pretty quickly. Anybody else have other questions? Yeah, okay.
I've heard some concerns about using speedy because of the head of line blocking problem at the TCP layer, where if you lose a few packets on the connection, the congestion window will shrink, and then you don't have another connection with a larger congestion window to pull its packets in. So I interpret that as kind of dragging out the tail. Some end users will get slow performance, but a lot of end users will get faster performance. Any comments?
Sure, yeah. So the question was, when you have one TCP connection with Speedy, what you can have is head-of-line blocking on the TCP side. Since HTTP is no longer a bottleneck, on the TCP side, if you start dropping packets, you block the entire page load, right? You don't have another connection that's being made to the server to kind of like handle the traffic there. So I guess I have 2 responses to that. Number one is that if you're making multiple connections to the same server, and that server's dropping packets, it's probably going to drop them across all the connections. Maybe you have one connection that's bad, but chances are they're going to be bad across all of them. The other point is that, yes, one of the things that happened with Speedy is that it did expose the problems with TCP. So when you fix HTTP, then you find out problems with TCP, which is the next layer down the stack. So yes, there are challenges there, but I think they're fairly rare. And you're right, maybe it'll make the long tail a little bit longer for some customers, but in the vast majority of cases, it's going to speed up the site. But certainly it does expose inefficiencies with TCP. And the working group that's currently working on HTTP 2.0 has been talking about sort of the next version of TCP as well. So maybe when they're finalized, they might move on and do that. Is there any point to implementing Speedy if all of your assets are served from a CDN? So if it really depends on the host name that's in use, right? And if the CDN supports Speedy or not. If you have a site where you're at foo.com and then all of your resources are coming from cdn.foo.com and your CDN does not support Speedy, and you turn on Speedy just for www.foo.com, you're not going to see really any benefit, much at all, because there's only one resource coming from that host domain. But that's what I was talking about, where if the CDN can support Speedy, then you get that huge win. And so that's kind of the ideal situation is when you have everything served off one host name, the same as the root domain. That host name is going through a CDN. The CDN is terminating the TCP connection and the TLS negotiation at the edge node, and then just passing that traffic through to you, and the CDN has Speedy on. That's kind of your ideal case. And just another quick word about TLS. People say TLS might be slow. Well, in the worst case, assuming you've got an optimized TLS deployment, it's really only one extra round trip for that negotiation. And if you're terminating TLS at the edge node, then your clients are doing that negotiation to a service very, very close to them. So ideally, TLS is only going to add maybe 20 or 30 milliseconds onto the page load time for that TLS extra round trip. So not a huge deal. And again, once you have Speedy, it's only one TLS negotiation for the entire page. So 20 or 30 milliseconds total, it's totally worth it for Speedy. And for the security benefits that you get from HTTPS. Does the TLS negotiation persist across pages? No, unfortunately not. It's that came with session cookies. Yeah, I guess that's right. You can put in session cookies and that'll help. So if you want to learn more about TLS, go to the TLS, is TLS fast yet talk tomorrow. Ilya knows a heck of a lot more than I do about TLS. Okay, I think I'm out of time for like one more question. Yeah.
Is anyone using Quick besides Google? I know it wasn't talked about in the presentation, but I know that kind of fixed the head of line blocking issue.
Yeah, is anyone using Quick besides Google? Not that I know of. So Quick is kind of like the next version of TCP, right? It's like the...
Yeah, there's some experimental thing on top of it.
Right, it's like an experimental protocol that is sort of could potentially someday take the place of TCP as a transport layer, right, below HTTP. I don't know if anybody outside of Google is using it, but that's the kind of thing that this working group might switch to work on kind of after HTTP 2.0 is done. And there's sort of, I think there's more low-hanging fruit on the HTTP side right now, just because this problem of tons of HTTP requests is like essentially completely fixed with HTTP. So that's really where the focus has been lately. And then once that's done, the focus will move down the stack to TCP and what we can do there. Okay, well, thank you for coming, and enjoy the rest of the conference.